Hello, everyone. Good afternoon. My name is Carlos Eduardo. I work at Red Hat. I'm a cloud architect. I work with our cloud products, mostly designing cloud platforms for customers. And also I have a side project that I've been working on for some months already. It's porting software from cloud platforms to the RISC-V. So I'm here to talk a little bit about it, the status that is on right now, how we came to that place. In case you guys take any pictures, please tag me on @CarlosADP on Twitter. And also, let's chat after this is over. So, RISC-V journey through containers to the cloud. What is it? What are containers? Most of the talks here in the summit are more related to hardware or software tools to aid in hardware development and creation. But also, I'm here to talk a little bit how we are now in the software front. So containers, what are containers? Containers is a way to have a standardized unit of software. It's a way to pack your entire application, its prerequisites, and all its dependencies into a complete image to be able to distribute it to any system that you have. Runs everywhere, from the developer laptop, your Q&A server, production cloud, or your on-premises servers, anywhere. So you pack your complete software requirements into a complete one single image, and you deploy to your cloud applications. Compared to a virtual machine, what is a container? A container is just the software that runs over your own kernel, the Linux kernel in this case. While in a virtual machine, you have a complete stack of a complete kernel running over a virtualized server. So you have a little bit of overlap and also overhead in features to have a complete virtual machine running on top of another kernel. So containers is a way to have it a lightweight deployment. You have a way to quickly start your application within seconds, of course, depending on your own application. But you don't depend on a complete, spin up a complete new server host over a virtualized environment. Also makes it lighter on resources, since you don't need memory and CPU to run your complete requirements. And can we have containers on RISC-V already? Yes, we can. So since a few months ago, I've been porting many software that is required to run containers. Most people know containers by the company Docker. Docker is the company that created the tool set and the complete tools to allow developers to run and build containers. That uses features from the kernel, Linux kernel, like C groups and namespaces, isolating the processes on these containers. So Docker was one of the tools that were ported. It already runs on RISC-V. I have some images already running, and you can see a small screenshot of building a Docker image and running it. And also, for people that don't follow too closely, Docker have a website that aggregates all images that you create for your own applications. For example, Apache web server, your own application, if you want to make it open source, you can create this package, this container, an image of your application, and upload it to Docker. That's called Docker Hub. That's the site on the left. And you can make this image available for anyone to run your application with all the requirements inside it. So you don't need to create the entire stack of installing for example, a Linux, then the requirements, then your web server, for example. It's all there. So you can create it all and upload, and I have made some images already built for RISC-V on Docker Hub. And container orchestration. Docker runs inside one computer, one machine. Your own machine for the developer, or a server. But once you start deploying it in production and to many servers, you need a way to coordinate all the servers that runs your containers for it to know where and when to run each of these containers. because otherwise it will start to become unbearable to handle all these different servers and which containers runs each of them. So you have a container orchestration platform. The mostly known one that everyone is investing time and resources on it is Kubernetes. Kubernetes was created by Google some years ago in an internal project. Then they upstreamed the project, and most cloud platforms nowadays uses Kubernetes as the base for their container orchestration. So what's Kubernetes? Kubernetes is composed of a control plane that's the master nodes that you can see on top, the blue image. That's the API server, some databases to control the state of the cluster. And on the bottom, you have the workers, the nodes that runs your workloads, your containers. So you apply to this unified control plane a configuration that describes how to run your container. That's a snippet, for example, on the left side of the slide. It's called a YAML file. It's a definition, a configuration language file that you tell to the cluster, deploy this application with this image name and some parameters, and it creates this container into the cluster. And the cluster itself allocates your image in any node that's available for the infrastructure. So you can have a full set of servers running your containers in a distributed way. Also, the cluster handles interruptions in the nodes. If your container is running one server and that server dies, it will reschedule your container into another server automatically. So you have a lot of resiliency in a cluster built that way. And you have orchestration in RISC-V as well. I've been achieving this in a couple months, like one and a half months back. I started porting all the functionality for having Kubernetes to build on top of a RISC-V, and it also runs. And also many other cloud-native foundation projects. That's Kubernetes itself, K3s, that's a lightweight Kubernetes, Prometheus, that's a database and time series database to collect and monitor your infrastructure, and OpenFaaS, that's a function as a service, or also called serverless platform, also runs in RISC-V. And how we got there? First, we needed Golang. Golang is a language that's compiled to bytecode to your target architecture and operating system. Go is still not upstreamed, but we have an off tree that already builds and passes all tests. Go is scheduled to go upstream, maybe in 1.14, that's the next release, but it could skip because of the amount of patches that have been submitted. So maybe it will skip to 1.15, that's around mid of next year, but it already runs perfectly. That's a tree that's kept over there, and we have a lot of pull requests, a lot of patches that have been submitted to the upstream project in the last few weeks. But as I said, it already builds perfectly and passes all tests on RISC-V. Then we needed the container runtimes, how to run the containers themselves on RISC-V. So I started porting and making Docker itself as the container runtime to be able to run on RISC-V, and then Kubernetes as the cluster operator, the cluster management cluster for containers, and also have been upstreamed. All code that you need to build these tools is already in their master trees upstreamed. There's a couple of patches that still need to be applied for them to be built by their own standard building tools, but the code itself in Go already builds perfectly with the master branch. No patches, external patches required. So what needed to go to that point? A lot of pull requests. I've been managing this for a couple of months since I started some months back before the Zurich RISC-V workshop, where I started submitting and tracking all the requirements to build these tools and the libraries that were required to pull them. And many projects and PRs later, we have all these tools working. So it was more than 20 projects that needed patching or updating to be able to build. More than 30 pull requests. For those that don't follow, pull requests is a patch to be applied on the master tree of the code. 6 CNCF projects, Cloud Native Foundation projects, and 95% or more of it is already upstream. You have like 1 or 2 patches still to be applied that have been tracked to be applied. And the container image list is growing. So this is all the images that I already built to be able to run on RISC-V on Docker. So you have the base containers. So for example, a Debian base image where you can build your own application on top of Debian image. I have the Prometheus images to monitor infrastructure, traffic, that's a proxy, Kubernetes itself, and other images. I also have a website to track this, all PRs and all images that have been published. Some issues that are still pending. So we have Golang scheduled to be up on 1.14, 1.15. SecComp, that's security on the kernel, is scheduled to go on 5.5. Linus already accepted that. Some libraries, Kubernetes, CGo for Golang, that's C extensions for Go, is still not developed, but it's not required for all this software, and some other dependencies that I can share the slides later. But most projects already built. And I'd like to do some demo, show you guys this running live. I'll be running the demo on a local virtual machine here in my computer. That's a QEMU virtual machine. This is a QEMU image, a virtual machine running Debian Linux. I made it available. Bigger? Better now? Yeah. So we have Docker running here. Docker built on the RISC-V platform, architecture, and OS type Linux. Also is the latest from 3, so development version. And we have many images running on this Docker instance here. So I have a function as a service platform that's a complete set of tools to allow you to only run and deploy containers with your own functions. You don't need to worry about where or when your functions are running. It's similar to Amazon's Lambda platform, where you only deploy the application. So for example, one application here is called Figlet. It just runs that MOTD generator. So I can switch here and do an echo. And this calls the OpenFast server over the virtual machine in QEMU and prints out the output. Also, we can see the OpenFast portal. It shows up all images that I have available. For example, Figlet itself. And I can invoke, and it generates the image for me. Also, it tracks all status using Prometheus. That's the metrics and collection platform. It's also running over here on the RISC-V platform. We have all information from it to gather, like for example, how many times this function have been run. For example, 3 times. And it shows up the build information. It's already upstream. So not only we have tools to build the hardware, the SoCs, but we also have tools to start deploying and using RISC-V as a platform for a service. And speaking about the orchestration software, I have a small video here that I can show you. This is Kubernetes installed on my own Unleashed board. That's the Sci5 Unleashed running Kubernetes. So I will SSH to the Unleashed. It will show up just the architecture that's running on. Is it showing? Oh, no. Oh, yeah. So all containers that's part of Kubernetes, all the control plane elements, the database, the API gateway, and all the tools running on the Unleashed, around 1.5 gigs of memory running, consuming all this control plane. So I have Docker running on it as well, because Kubernetes needs Docker to be able to spin up those containers, so it's a requirement. And the nodes, it will show the Unleashed node as it's running itself, all the containers. So we can see that's running a Debian Linux and allowing all containers to be scheduled on this node. It has labels showing that's a RISC-V node, so it's able to run. And these are all the containers running already inside this node, this platform. So this is OpenFast, the similar platform that I have on my own VM. I also have on the cluster running. We see all the accesses, so we can go to the URLs that's mapped inside the cluster and show up the tools that's running inside the cluster. So Prometheus here, built from the RISC-V branch. And also what's monitoring right now. So it's monitoring the OpenFast gateways to be able to collect all the stats on the tools that are deployed inside OpenFast. So you can grab like the gateway image and open the URL and open the website. Also running the similar function. That's a function that generates the MOTD tags. Also, it tracks the invocations and how many calls it's being used. And we can create additional tools to be deployed in this cluster. Any kind of containers should be able to run here. Here's another tool that I developed just as an example. It's called an echo server. I'm deploying it inside the Kubernetes cluster. It creates the default manifests for me. When I create it, it will show up in the bottom. So here we have in the bottom the Echo application that's deployed inside the cluster. The status is container creating because it's still fetching and spinning up in that node the application. Then I will expose the service on port 80 because it's a web server. And create a URL for it inside this cluster. So I will be able to access my application that's deployed inside the cluster. There it is, it creates the URL for me. If you look at the container below, it's already running. And I will open a new window, and it shows up just a text that's a web server. So we have all elements, the service, the pod, that's the container itself, and the deployment of the application inside the cluster. And that's it that I wanted to show you guys, that it's able to run multiple applications. Please contact me, let's keep in touch about this. We need help to be able to have more tools in Go. C-Go is a requirement that helps a lot on many tools. Also, I keep a tracker for all development and new projects that I've been porting on the RISC-V Bring Up repository back there. Also, ping me on Twitter. And any questions?
I'm just wondering, have you ever tried on some real RISC-V CPU, or it's
No, the cluster that I showed the video is running on the Hi5 Unleashed board. That's a real hardware. I record the video because I wouldn't be able to bring the board here for the demo. But it's running on the real CPU. Yeah. And also the VM is available on the tracker. If you look at this RISC-V Bring Up tracker page, you can find a tarball, a tar gzip file with the RISC-V complete virtual machine with the script to start it like I did here. Also in the same page, you can find the Docker download to install on RISC-V. It's an off-tree build because Docker don't supply the binaries themselves yet for RISC-V. So I built and created a package to install. And also you can get Golang tarball as well to be able to install in this virtual image and start developing Go applications.